All right, good morning. I am going to go over this. Whenever you watch this, it may not be morning, but I am recording this in the morning before Friday morning, and this will be your homework. My periods 3 and 5, and possibly Miss Santos's first period. So if you're here, great. If you're going to get through this stuff is actually super important that we talk about, and then we're going to get into something a little bit for next week. So for this problem, Valerie has already ran 4 miles and then runs 2 miles every day. Charles has already ran 10 miles and just runs 1 mile per day. If you remember, let me go ahead and do this on this screen. What would Valerie's equation look like? All right, if we look at Valerie, we'll put it up here. Oops, let's use a better color. Y equals keyword, ran 4 miles. This is something that's already happened. This is our starting point. This is our y-intercept, okay? So that would be at the end of the problem, okay? Then runs 2 miles every day. 2 miles every day. You could change this to x, that's fine. And to be honest, this is 2 miles every day plus 4 miles. So what should this be? How about that? How about we make that miles? Again, it's also known as y equals, don't get too confused, 2x plus 4. And we should be getting much, much better at this, understanding what's going on, understanding what the y-intercept is, understanding what the slope is. All right, now, let's go ahead and do this other one. Charles has already ran 10 miles, all right? My miles equals, for Charles, we're going to start with 10. He already ran 10. And then he runs 1 mile per day. 1 mile per day, okay? But like I said, it could also be y equals 2x plus 4. Now what are we going to do? Well, if you learned in the lesson, we're going to set these equal to each other. This guy right here, let me get a better color. Let me get a better one that you can actually see. Wow, that one does not want to work. Okay, so let's go ahead and set this. These both equal m, right? Or y, what we learned. You're allowed to set these equal to each other, okay? And solve it. So that's what we're going to do. You want to do this on your notebook. You want to take notes. You want to submit all of your work for extra points. I will accept that. Let's go. Let's go ahead and do this. So let me go ahead and I'm going to write this on my notebook first, and you'll see my notebook in just a second. Now, one thing about this, you see the 1 day here, 1 day. You know in algebra, they don't have to put the 1 there. They could decide the 1's gone. And you have to know that that's 1 day. There's an invisible 1 right there. Isn't there an invisible 1? Don't forget about the invisible 1. Okay. Now, to my camera. All right. Again, we can post for extra credit. So, if we're going to solve this one, I want to make sure we're going to go ahead and I'm going to go ahead and subtract letters to the left. All right. That's going to end up being 1 day. 2 minus 1 is 1. Plus 4 equals 10. And then my last step would be to subtract 4. So 1 day, I don't need to put the 1 there anymore. So my days actually equal 6. So what does that mean again? I got 6. Hopefully you got that too. But if I go back to this part right here, after how many days will they have ran the same amount? How many days will it take for them to have ran the same amount? 6 days. Well, they'll have the same amount of miles. After 6 days, same amount of miles. Okay? All right, what if it asked you? So I'm going to write these equations out again. I know they may look a little different here. Y equals 1d plus 10. All right? Now, what if I said 6 here I totally messed with you because that's an x too. But you're going to plug it in. If I put this for D as well, if it's 6 is the first answer, that's our x, or in this situation, that's our days. Our y is going to be our miles, if you remember. How many miles did they run after 6 days? How would you figure that out? How many miles did they run after 6 days? Plug in the 6. 6 times 2 is 12. 12 plus 4 is 16. Let's make sure that's true. What if I put 6 here? 6 times 1 is 6, plus 10 is 16. So they ran 16 miles. Now on these problems, they're usually just going to ask you one or the other. They're going to say, how many days or how many miles? All right, cool. Now, let's just go over one that you should have seen in class. What if I said y equals 4x plus 5 equals y equals 2x plus 29. All right, how are you going to solve this one? Let's make sure that we are, again, setting them equal to each other. This one's going to go, and guys, can I just show you the idea of this? So what does all of this equal? What does that box equal? And in class, we would do an activity like this. What does that card equal? That card equals y. This is what we're going to talk about next week. So all of this 4x plus 5 equals y. So if I asked you what does y equal, you could say 4x plus 5. And then what you're going to do is you're going to plug in where the y is. So I'm going to cross the y out, and I'm going to put my card in for the y. And I'm going to write it out. Don't worry if you're kind of lost right now. We're going to get there. This is all stuff that we're going to talk about next week. Setting them equal to each other. Go ahead and solve the equation for me. Okay. Now, what I was talking about a second ago, we're going to start to look at how to solve equations like this. So if I said y equals 2x, okay, plus 0. There's nothing over here. There's no y-intercept. And then I said, check this out. This is going to get kind of crazy. You're going to get kind of flustered here. 2y plus 4x equals 12. What? What are you doing to us, Marusik? Slow down. They can write equations like this too. And this doesn't look good to you because you're so used to seeing equations written out like this, right? mx plus b. Well, there's also another way where they could put an x plus a y equals your number, equals like 4. They could write it out like this too. All right, this is called slope-intercept form. This is called standard form. This is in standard form, even though the y and the x are in separate spots here, which I did that on purpose as well. All right, if I asked you in this question at all, either one, look at either one, could you tell me what y equals? Could you tell me what y equals in either one of these problems? Well, if I look at this one, I have 2y plus 4x equals 12. That doesn't really tell me what one thing equals. That tells me two things here. These two things equal 12. But what about here? What does y equal? 2x. Y equals 2x. Look what I'm going to do. All right, I'm going to go ahead and, Marusik loves his little clouds. Put little clouds around the 2x. I know that 2x equals y. Plug in. Another word for this is substitute. Substitute. So if I was ever absent and we were in person, if we were in person in class and I'm absent, a substitute comes and replaces me. You're going to replace, this is Mr. Marusik this is actually the sub. This is the sub. This is Mr. Marusik. Why is it the y? What does y equal? 2x? We're going to take this 2x and we're going to replace it. We're going to plug it in. So now I'm going to put it in where I see a y. I'm going to substitute it. I'm going to substitute it. So this is gone. The y goes away. And what do I put in its spot? the 2x. This gets a little confusing, pay attention. So I have 2, I'm going to put parentheses, plus 4x equals 12. I wrote the same equation. But now there's a 2x here. There's not a y because we know we can replace the y with what we know y is. Our whole goal for this, guys, is to get rid of one of the variables so we can solve for the other one. You can't solve for x unless you just have only x's in an equation. Before we had y and x. That doesn't work. Now, how are we going to get x to be by itself now? Does this mean multiply? 4x plus 4x equals 12. And Mr. Marusik messed up, but it's okay. We're going to get there. I'm not mad that I messed up. I'm going to get 8x equals 12. Why did I get 8x? Remember, you can combine like terms. And then what do you do at the end? You can leave this as an answer, or you can reduce it by taking 4 out of it. All right, so then you're going to have, it's okay to have fractions. I know, that looks kind of confusing. The whole idea was to understand that you're going to have to plug stuff in to the other equation. You're going to have to replace stuff, okay? All right, guys, this was just a little heads up of what's going to happen next week. Don't worry if you're still kind of lost. I want to make sure you still get that you can see equations in 2 different forms and that you can actually plug stuff in.